Here's one from the book. Find the area between two curves. In this case, y equals e to the negative x and y equals log x on an interval from 1 to 2. So there's basically two ways to do it. The first way, we identify what area we're talking about here. And we are talking about this green area here, here, and here, from 1 to 2 between the curves. So here and here. So there's your area. But and we notice we want positive area. So to the left of the intersection point between the two curves, which is right here, e to the negative x is above log x, and after it's reversed. And we want positive area. So we're going to find this intersection point, and we could try to solve it algebraically, but that's going to be difficult in this case here. So we're going to use second calc intersect. Second calc intersect, and that turns out to be 1.3098. So the area is going to be two chunks added together. First chunk is 1 to 1.3098 of the larger function minus the lower. So above minus lower, so you get a positive number. And then 1.3098 to 2, the rest of it, where log x is bigger than e to the minus x. So that's positive. Then you run the calculator program, and we'll learn how to integrate these by hand coming up very shortly. But right now we're still using the calculator with n equal 100 and the trapezoid, which is the left Riemann sum plus the right Riemann sum, all divided by 2, the average of those two. So you get 0.0543, and doing that for the second interval you get 0.2081. So that results in the area between the curves from 1 to 2 being 0.2624. Now the other way to do it is just run the integral over the entire region and just make sure all the function values for the differences are positive by doing the absolute value. Do the absolute value here. So we just run this absolute value, and that makes sure that the values of this subtraction are positive, and we run the trapezoid method with n equals 100 intervals, and you get the same value. So it does work. The only difference is you really will need to break up the integrals if you're going to find the exact value of the positive area. When we integrate and actually find these antiderivatives of these functions, the absolute value is going to cause a trouble. You're still going to have to break up the integral and find that intersection point in order to then integrate.